Dr. K.S. Ramakrishnan is working as an assistant professor, School of Education, Tamil Nadu Open University, Chennai 15. He has been teaching science education, environmental science, educational technology and research methodology in various colleges of education and Tamil Nadu Open University for the past 9 years. He has guided so many M.Ed, M.Phil and PhD students. His current research areas are environmental education, educational technology and media and communication. He has conducted various workshops on ICT usage in education, Wiki Educator, e-content development and educational research methodology. He had attended many online workshops on Moodle, learning analytics. He has published 6 books and many articles in national and international journals of repute. He regularly gives plenary and keynote speeches on environment and ICT related issues at various national and international conferences. He has delivered 28 episodes of the program Pudiyodor Ulagam at All India Radio, Chennai, related to various new developments in science and technology.
Welcome to UGC CEC program. In this episode, we are going to discuss about the air pollution monitoring. The major contents we are going to discuss are the types of air pollution, the pollutant standard index and various types of monitoring the air pollution. So, these are all the topics that we are going to discuss today. And what are the major pollution in Asia? Asia is one of the most polluted places in the world, and in Asia the China is the most polluted. What are the major pollutants of China? Sulfur dioxide 15 million tons and the particulate matter 20 million tons are produced, and the major reasons are high sulfur coal usage to generate energy and other chemicals, the carbon dioxide, the greenhouse gases, nitrogen oxides and acid rain. So, these are all the major pollutants as far as China is concerned. And as far as India, the major pollution is from the suspended particulate matter. See, for example, in all the cement industries or the coal industries, a lot of dust particles are produced and they are going to the atmosphere, and they are the major pollutants as far as India is concerned, and India is producing around 45 million tons of ash annually. And South Korea, sulfur dioxide, and Hong Kong, the diesel powered engines are the major culprits. And the types of air pollutants. So, we can divide the air pollutants into primary air pollutant and the secondary. The primary air pollutants, they are directly emitted by the sources itself, and the secondary, when these pollutants are reacting with air or any other natural or the artificial materials in the surrounding, they are producing the secondary pollutants. For example, the carbon monoxide, carbon dioxide, sulfur dioxide, nitrous and nitric oxide, most of the hydrocarbons, and they are directly produced by the pollutants. But when the carbon monoxide or the carbon dioxide or sulfur dioxide, they are reacting with water or some other material, they are producing sulfur trioxide, nitric acid, sulfuric acid and hydrogen peroxide, ozone, etc. So, these are called the secondary air pollutants. So, either the pollutants may be classified in the primary or secondary, but both are harmful as far as the pollution context is concerned. And in the diagram also that it is given. So, these are all the direct pollution and they are producing the secondary pollutants, and these are all the stationary pollution and these are all the mobile pollution. So, they are produced in both ways. We are going to discuss about the pollutants separately. Mostly 5 major materials released directly into the atmosphere in unmodified form: carbon monoxide, sulfur dioxide, nitrogen oxides, hydrocarbons and particulate matter. So, these are all the most major materials released directly into the atmosphere, unmodified forms. And carbon monoxide, what are the various forms that it is generated by burning of organic material, coal, gas or wood. Automobiles, most of the carbon monoxide is produced from automobile. So, when the fuel that is combusted in the internal combustion engines, it is first producing the carbon monoxide, and when the carbon monoxide is reacting with oxygen, immediately that it is producing the carbon dioxide. So, carbon monoxide is mostly produced by the automobiles and the cigarette smoking and the hemoglobins, and they are reducing the oxygen in the blood, and it is not a persistent pollutant, combines with oxygen, that is what already we have discussed, combines with oxygen to form carbon dioxide, and most communities now meet the EPA standard, that is the pollution standards, but the traffic can produce high carbon monoxide levels. So, if the engines are very efficient, they are not producing much carbon monoxide, but when we are using the less efficient engines, then they are more prominent producers of carbon monoxide levels. And next, the sulfur dioxide. So, the sulfur dioxide mostly produced by the burning of major sulfur content. Most of the coal and petroleum, they are having a lot of sulfur content, and the coal burning power plants, they are the major pollutants, and it is reacting with the atmosphere to produce the sulfuric acid, and when that acid is dissolving into water, that is producing the acid rain, and therefore, it is a chain, it is a some sort of a chain, and when inhaled, it is directly going into the lung, and it is corrosive the lung tissue. So, most probably those who are working in the industry, the coal industry, coal and petroleum industry, they inhale a lot of sulfur dioxide, and therefore, the lung tissues, they are corroded, and finally, that they are getting a lot of physical problems. And then the nitrogen oxide, it is also produced by the burning of fossil fuels, and it is also producing the acid rain. The only difference is that it is producing the nitrous and nitric acid, NO and NO2, and the automobile engines are the major sources, and the new engine technologies, they are highly controlling it, but still in most of the third world countries where the technologies are not developed that much, it is still a problem. And then the hydrocarbons, again they are produced by the fuel industries. The hydrocarbons are the organic compounds with hydrogen and carbon, CH4, C2H6, all these are the hydrocarbons, methane, ethane or alkanes, all the alkane family, and they are produced by the incomplete burning of the fuel supplies, and it is contributing to smoke, because the CH4 molecule CH4, it is somewhat bigger, and therefore, when it is combining with the fog, then it is producing the smog. Actually, the smog that is affecting the visibility also, and therefore, it is a major pollutant as far as the visibility aspect is concerned. And then the particulate matter, are the particle, physical particle whose dimensions are somewhat bigger, 2.5 millimeter to 10 millimeter, that means it is somewhat this much bigger. Ash from the fires, the asbestos from the brakes and insulation, and the dust. Most of the coal industries are the topmost producers of this type of pollution, and they are easily noticed, the the smoke coming from the industries, and it consists of a lot of smoke material, and they can also accumulate in lungs and interfere with the ability of lungs to exchange the gases, and some particles are carcinogen, that means they are able to produce cancer, and so again it is also a major pollutant. And this is an example. See, they are easily visible because their size is somewhat bigger and therefore easily they are visible, and mostly the cement industries, the particulate matters are somewhat white, and here the coal and petroleum industries, they are somewhat black in color. And the secondary pollutants are mostly produced from the primary pollution, and the major players in this type of pollution are ozone, peroxyacetyl nitrate PAN, the photochemical smog, or the aerosols or mist. Now, let us see them one by one. Ozone, it is one of the most major pollution, and it is a highly reactive gas of 3 oxygen. That means, when 3 oxygen molecules in the presence of the ultraviolet rays, when they are colliding, then they are producing O3. That means, 3 O2 is producing 2 O3, and therefore, as it is coming from oxygen, we are calling them as the secondary pollution, and it is from the natural form and the man-made, occurs in the earth upper atmosphere, stratosphere, and lower atmosphere, troposphere, and the ozone that we are breathing is formed primarily from photochemical reactions between 2 major classes of pollutants, volatile organic compounds and nitrogen oxides, and therefore, they are available in the atmosphere also, but as far as we are concerned, we are inhaling most of the ozone produced by VOC and the nitrous oxides, and it is one of the most major pollution. And the smoke, it is caused by the interaction of some hydrocarbons and oxidants under the influence of sunlight, and it is giving rise to dangerous peroxyacetyl nitrate or PAN, and it is affecting the visibility, and particularly in winter season, the smoke, it is causing a lot of problems in the industrial towns, and sometimes even up to 10 o'clock or 11 o'clock, particularly in places like Delhi, the visibility is highly affected in the suburban area where the industries are high in number. And here in this diagram that we are portraying all the types of pollution, and that we are going to discuss them in detail. And the photochemical smog, a mixture of pollutants such as particulates, nitrogen oxides, ozone, aldehydes, peroxyethanol nitrate, and unreacted hydrocarbon. When all these are combining together, they are forming a brown haze due to the presence of nitrogen oxides. It causes painful eyes also. That is why it is called the photochemical. So, it is all kinds of chemicals, and they are affecting the photosense, and so they are called the photochemical smog. And it is simply speaking, when all this matter are joining together, they are forming the photochemical smog. And here in the sunlight, that they are all reacting, the nitric oxide, nitrogen oxide, and so in the sunlight, when all these are reacting, they are forming the photochemical reaction, and the photochemical smog is formed. And the aerosol is a kind of substance which is very light, and they have the property to reach the upper atmosphere very quickly and easily, and very fine liquid droplets that cannot be effectively removed using the traditional packed scrubbers, and they are formed by the gas phase hydrolysis of halogenated acid. That means, the hydrochloric acid, hydrogen fluoride, hydrogen bromide, etc. And therefore, as they are very light particle, they are reaching the atmosphere, and therefore, they are reacting with other chemicals or other material, and they are also causing the pollution. Here it is the type of pollutions, and in the stratosphere, that the upper atmosphere and the lower atmosphere, all this kind of pollution, the nitrous oxide, nitric oxide, and therefore, due to the sunlight and the heat, the sulfur dioxide, that is giving sulfuric acid, and similarly each chemical that is giving birth to another chemical, and therefore, it is a cyclic reaction from one to another, another to another, like that this cycle goes on repeating. And so, the problem is that once the pollution is started, it is very difficult to stop it, and therefore, the best advice is that we have to stop the pollution at the starting, at the origin itself. Once the pollutants are released, then we cannot predict what kind of form that it will take after some time. So far we have discussed about all the kinds of pollution. Now how to monitor? For monitoring we need some index or we need some measurement, and one such measurement is the pollutant standard index, or it is called the PSI, and it is an indication of the pollution level and the uniform method to classify and report urban air pollution. Mostly the pollution is a phenomenon in the urban, and therefore it is a measurement for the urban pollution, and there are 5 criteria under which that we can classify. And the first one, the hazardous condition. If the PSI is greater than 300, it is very hazardous, that means it has gone beyond the dangerous levels. And very unhealthy condition, if it is from 201 to 300, then it is unhealthy, that means it is definitely dangerous, but it is not as dangerous as the higher level. And then unhealthy condition, that means 101 to 200, that is unhealthy condition. And then moderate 50 to 100, and then the good condition 0 to 50, that means at any point some kind of pollution is there that we cannot stop, but anyhow that for our all monitoring problem that we are dividing that into this 5 category, and therefore they are continuously monitored, and when in a particular place it is going beyond the limit, that we have to interfere. And the urban pollutants. So, these are all the urban pollutants, the suspended particulate matter SPM, and the same carbon monoxide, hydrocarbon, sulfur dioxide, nitrogen oxides and ozone. So, these are all the most, see the one thing that is very clear, wherever the automobiles are there the sulfur dioxide is present, and carbon monoxide and carbon dioxide, these are present. And therefore, the automobile industry is the major pollutant. And now how can we monitor it? The source monitoring, stack sampler, and the parameters, that what parameters that we can fix. The pollutants, the velocity, the temperature and pressure. So, what kind of pollution, the velocity, temperature and pressure. So, these are all the major parameters. And now the point, sulfur dioxide, nitrogen oxides, carbon monoxide and particulate matter. So, these are all the source, and these are also the source, the carbon monoxide, nitrogen oxide, etc. And as per the World Health Organization standard, some are the essential and some are the additional, that sulfur dioxide, nitrogen oxides and particulate matter, these are very much essential, and the hydrocarbons, carbon monoxide and ozone, they are additional, that means they are very much important and they are important. So, in that way that we can divide. And the criteria, so dependent upon the use or purpose of the result, and they have to comply with the air quality standard also, and to evaluate the impact of new or existing air pollution sources, and the impact of hazards due to accidental release of chemicals, and data may be used for research purpose. So, these are all the criteria. What are the criteria? In a simple way we can say they have to comply with all the standards, and they have to, the data should be able to be used in other purpose also, otherwise there is no use at all, and therefore, on this criteria that we have to monitor. And the type of monitoring A, B, C and D, E, F. So, in that way the monitoring is happening at different places, and type A, it is the downtown pedestrian exposure station, and therefore, it is directly put up in the places where the people are crowded, that means it is in the congested areas, and therefore, where the vehicles are flowing more than 10,000, in that places it is monitored, that is type A. And type B, it is not directly at the place, but it is in the nearby places where the vehicles are less than 500. That means, in the road if you are monitoring type A, and in the street surrounding the road if you are monitoring, it is type B. And type C, the residential population, then it is type C, that means 100 meter away, that is type C. And type D, that is in the mesoscale station, appropriate height to collect meteorological air quality, that means at a height, that means on the top of the building or some sensors. So, these are type D. And type E, non-urban station, very remote stations, if you are monitoring, that is the type E, where there is no traffic, no industrial activity. That means, what is the purpose of all this type of monitoring? We want to check to what extent that the pollution is spreading into the places, that is the major motive of all this type of monitoring. And type F, that is specialized source survey station, and particularly that they are at a very remote places, sometimes even balloons or some remote satellites also, and therefore, in these 6 ways that we are monitoring. This is the typology according to where we are measuring. So, for that we are dividing that into the 6 types, and then here the gaseous pollutants, continuous monitoring the particulate matters once in every 3 days. So, in the time frame also that there are differences, and the gaseous pollutants are constantly monitoring, that means every second or every millisecond that they are monitoring, but the particulates once in every 3 days. What is the reason? Because the particulate matter gradually that they are accumulating, and therefore, once in 3 days or once in 2 days, that is enough for it, how much amount is deposited. And the gaseous pollutants, because they are very dangerous, sulfur dioxide and carbon monoxide etc., therefore, they are monitored continuously. And the number of station, the number, and the minimum number is 3, because the triangulation statistically at least at 3 places if you are taking the measurement, then it is very much useful for taking the averages. And the location dependent upon the wind rose diagram, that means it must be related to the wind also. Sometimes what will happen, the pollution may be produced at one place, but because of the wind it may be taken, carried away, and it may be deposited in another way, and therefore, it all depends upon the wind velocity and wind conditions also. And one station must be an upstream, that means at least one station out of the 3 stations must be in the upstream, where the predominant wind direction, and the other 2 must be at downstream and according to the wind direction. Suppose if the wind is flowing in this direction, one is here and 2 may be here. So, in that way we have to place the monitoring stations, and more than 3 also. 3 is a minimum condition, but you can place as many as possible, 6, 7, 8, it depends upon the accuracy that you want. And this is a kind of monitoring station, they continuously monitoring. Actually nowadays they are packed, that means if you are constructing a monitoring station, it will monitor most of the material. A typical monitoring station includes sophisticated gaseous pollutant analyzer, collector, weather sensor, and they are constantly maintaining it, and therefore, nowadays they are very sophisticated, and therefore, we need not bother much about how they are monitoring, but actually they are able to give the good prediction. These are all the types of instrument that we are using, and the emission monitoring, ambient monitoring, deposition monitoring, and here and it is placed, and therefore, once in 3 days that we can monitor the deposition and the health monitoring and upper air monitoring. That is what already we have discussed, and through the balloons that they are static at a particular place or they may be moving also, and therefore, we can monitor them, and like that there are so many instruments now. And monitoring types, emission monitoring, it focuses on the emission out of natural and man-made sources, ambient air concentration and toxic and non-toxic contaminants, that is ambient monitoring, deposition monitoring, dry and wet deposition, visibility monitoring. That means, depending upon the purpose that we are monitoring. In emission monitoring, our main aim is how much emission. In deposition monitoring, how much is deposited. Visibility, here the main motive is to what extent that they are affecting the visibility. And health monitoring, what are the health hazards associated with the monitoring, and therefore, these are all the various purpose behind the monitoring. There are some other purposes also, and the instrumentation, concentration measurement instrument and the continuous emission monitoring instrument and the air measuring devices, and they are the volumeter, rate meter, velocity. So, that they are monitoring, and the meteorological instrument, they are the basic devices used for measuring the atmospheric variable. So, therefore, once we are monitoring, we are measuring the other parameters also, for example, the air velocity and all. Why? Because depending upon the air, for example, if carbon dioxide is produced at a particular place, if wind is very high, it may be deposited after some 10 kilometer, and therefore, by the way that we are measuring the velocity of air also, temperature also, because when the temperature is low, the deposition will be at lower places. When the temperature is high, when the air is rising above, naturally that they are deposited at a higher place, and therefore, when we are monitoring, we have to monitor all the other parameters as well. And these are all the devices used for that, concentration monitoring, continuous monitoring, and so on and so forth. And the air sampling system, so they are sampling the air, and they require gases or particles to be drawn to the surface, and therefore, the sampling system, they are sucking the air inside, and then that they are collecting the information, and they are utilizing the filter to present the particles, and these are all the impingers, and so here they are sucking and the vacuum tube, and after that they are monitoring the impingers. And air sampling procedure, so they may be static or they may be intermittent also, and they are grabbing the sampling, not commonly used to monitor ambient air quality. And the source sampling, that they are sampling through the source. Let us summarize now. In this episode, we have dealt with various kinds of air pollutants, the pollutant standard index, and various kinds of monitoring mechanisms for monitoring sulfur dioxide, carbon monoxide, nitrogen oxides, ozone, particulate matter, etc. Actually, the monitoring is a continuous process, and therefore, we shall discuss some more in the next episode also. And now, let us have some questions. The first question mentions some urban pollutants in India. The second one, define the pollutant standard index, and third, how particulate matter is monitored. With these questions, we are concluding this session, and thank you.